So the motivation behind our system is to be able to provide climbers with next step suggestions of where to go from their current configuration. If they're holding, 3 or 4 grips in here, where should we go? Should we go to these 4 grips, these 4 grips? And our system can sort of compute an ideal path and then give them the next step in that ideal path continuously. And even if they waver from the ideal path, if they choose something non-ideal, our system will just adapt and constantly sort of recompute, okay, should we go back? Will it still be ideal to go back? Or maybe since we moved a little bit, is it ideal to continue on this path in some route, along some route? So the way our climbing system works is we have a set of nodes, or climbing grips, you could say. And for each of these grips, we create a group. So this grip has its own group, this grip has its own group, this group has its own group, etc. And once each grip has a group, we neighbor the close groups. So this guy has neighbors here, this guy has neighbors here, these guys might have neighbors up there. So everything that's close by each other is neighbors. And the reason for this is so we can perform A star. A star needs to know, okay, where can I go? What is the network? And this is our network. A set of lines or paths between clusters. And each cluster is a climbing configuration. So within each cluster, a climber should be able to stand. And what we're saying with these neighbors is, from this cluster, you should be able to climb to this cluster or to this cluster, but not this cluster way over here. You can't leap all the way over to the cluster over here, but you can sort of climb your way into a close by cluster. So you can go from one configuration to another. And we don't optimize by distance, we optimize by energy, where we use, for the Y component, we decompose each direction, and for the Y component, we say, alright, let's use MGH, potential energy. So the higher you climb, the more potential energy you get, and the more of that energy you use to get there. And in the X direction, we use work, or FS, force times distance. For the force component, we say that it'll take the climber approximately 1 second to get from one configuration to another, which lets us sort of create an average force. And from that, we just multiply this average force by our distance between two setups, and that gives us work. And so we add these two components, the Y component and the X component, and that gives us sort of a force or energy vector or whatever, how much energy it takes to climb a certain slope or distance. And we use this as the input to our A star function. So our A star has essentially what the A star sees is a set of clusters with a certain configuration. i.e. Each cluster has a certain neighbors, and you start down here, and up here is your goal. And it computes, okay, how much energy do I need to go there through the aforementioned technique, and then it just finds the paths that use the least amount of energy. And that is how we solve, and the climber then moves from configuration to configuration, each one being sort of the ideal in terms of energy used, least energy used. And that is what our climbing system is based on. Climbers can climb a route based on two metrics, or compare themselves based on two metrics. Given that they succeeded climbing the route, it's either time or energy. And very often climbers spend their effort in the energy domain and improving their skills on energy used. They want to optimize for energy. And so a climbing system that can give them a little pointing pin, you could say, about, okay, which routes potentially have the least, use the least amount of energy, that's a useful tool to a climber. Our simulation is currently done in Python. We use a module called Pygame, developed to make video games, but is equally good at providing a simple 2D palette to run a simulation on. Simulation.py start. So we just draw a very simple sort of white block. This is the wall. These are the holes that you can put the grips in, and the blue dots here are the grips. And then the starting grip is the pink one, ending grip as well. And the blue circle here, that's where the user is. That's sort of the cluster of grips, the configuration that the climber is currently on. And the red is the configuration that the system recommends. So, and potentially in a real world situation, the green ones here could be LEDs, lights, or any sort of indication on the grips that these are the suggested grips that you move to. This is the configuration. And you can see if we start following it, it provides us with constantly updated suggestions of where to go, of which configuration to move into from the current configuration.